Okay, let's look at this question here, which is on vectors, right? Taken from 2016 paper on question 11. So the plane has this equation. So we have two vectors here which are parallel to non-parallel vectors, which are parallel to the plane. Then this is a point on the plane. Okay, this is a parametric form. Point on plane. Okay, so if you want, you can just draw it out. So this is how we draw it out. You have two directions. So this guy, the point on plane will be 1 minus 3, 2. Then after which this m1 here will be 1, 2, 0, and m2 will be a4, negative 2. Okay, this is what I'll do. Usually I'll just draw. So just practice drawing. You would know how important drawing is, right? So basically, usually difficult questions you can't get away on. You just draw a few things, try to understand it, it should be okay. So the line has this equation here. So straight up, I know this is a position vector of the line. Then this is actually the direction of the line. So I can also draw it. So I'm just, if you want to, you can just draw it out. I'm going to draw it out. Just draw a line. How hard can it be? So this is a line here. Then D is actually negative 2, 1, 2. Right? That's it. Alright, I think the first one, the case A goes 0. When A is 0, show that L is perpendicular to P. Now, if L is perpendicular to P, meaning to say, if L is perpendicular to P, right? So essentially, the direction of L will be parallel to the normal of the plane. Am I right? This is L, this is P. So meaning to say, if L is perpendicular to P, you need to show the direction of a line is parallel to the normal. When A goes to 1, or A goes 0, I know that the direction vector is this guy, minus 2, 1, 2. The normal is equals to, you need to cross them. So it's just 1, 2, 0, cross with 0, 4, negative 2, right? So the normal will get 2 minus 2, 1, 2. So since n is equals to twice of d, this shows that normal is parallel to plane. Okay, so you just show the normal is parallel to the direction of the line. Then after which you can show that L is perpendicular to the plane. So it's just this analogy here. So you know that because what they want is so I'm going to equate this both to solve for lambda and mu because they equal to each other. Okay, so you just take the equation of the plane equal to the equation of line, then you can actually just solve them. So this case here, by using this, we know that this is 1 plus lambda equals to minus 1 minus 2t. Minus 3 plus 2 lambda plus 4 lambda mu equals to t. Then 2 plus minus 2 equals to 1 plus 2t. There will be 2t plus lambda equals to minus 2 minus t plus 2 lambda plus 4 mu equals to 3. Then you have got minus 2t minus 2 mu equals to minus 1. So just don't forget there's a 0 here. And there's a 0 here. Key in calculator from GC. Minus 5 over 9. Lambda equals to minus 8 over 9. And mu equals to 19 over 18. Great. So they didn't ask for coordinates of point of intersection. So I think just solve for the parameter. That will be enough. Part B. Find the Cartesian equations of the plane such that the perpendicular distance from each plane to P is 12. Okay, so this is the case here. Let's try and understand this. So part B. I think we still need the scalar product form for the first. So I think we just find the scalar product form of r dot n. So r dot n, which is 1 minus 3, 2, right? So this will be taking a point from the, the normal is not 1 minus 3, 2. The normal is negative 2, 1, 2, the normal of the plane. Then a point on the plane is given, which is minus 1 minus 3, 2. So 1 minus 3, 2 dot minus 2, 1, 2. Minus 2 minus 3 plus 4, which is actually minus 1. So hence plane equation will just be r dot minus 2, 1, 2 equals to minus 1. Is that right? Now what we want is, okay, let's say this is plane P. So this is P. Or plane P, huh? Okay, actually it's P, so I don't need to put up pi. If you want to find the planes which are perpendicular distance from each plane, the only time when it's perpendicular, a plane have a perpendicular distance is when they are parallel to each other. Is this okay? You understand? So essentially, you can only have planes which are parallel to, you can only have perpendicular distance when they are parallel to each other. So essentially, this is 12 units. This is also 12 units. Okay. The next one will be this P1 obviously is r dot minus 2, 1, 2 equals to, let's say, K1. Okay. So this P1 here is, you still can use K2 if you want to, but essentially they both have the same formula, right? Because they are parallel to each other. Okay, they are parallel to each other. The distance between them, distance between two parallel planes, you can just use the distance formula between two parallel planes is equals to this scalar. Okay, once the normal is the same, you just take this scalar multiple, this constant here, this scalar multiple constant, so it's k1 minus 1. Actually, I can just put this as k. Okay, just take k minus 1 divided by the 1 minus 2. Is this okay? So you just, the formula is k1 minus k2 over mod n. Okay, so I derived this before, so I just leave it. You can just Google search how to find the perpendicular distance between two parallel planes. My video will likely come up. So you just put this as 12. Remember the mod now, okay? So this is square root. That will be 9, so 336. So k plus 1 can be either 36 or negative 36. That will be k. R dot okay, so this is it. You get the two possible equations. So this is you can just use the formula. So I'll just label this as method 1 using the distance formula method. So if you use method 2, you don't really need to memorize because you're actually deriving the distance formula using magic triangle. So I'm going to explain how do you actually do that. So what you do is pretty simple actually. What you do is you want to find k. The normal vector here is what? What's the normal vector here? The normal vector here is negative 2, 1, and 2, right? So now my question to you is, if you want to use magic triangle, you need a point on the plane 1 and also point on P, right? Is this okay? So my question to you is, can you guess a point on plane 1 for me? Any point here? Any point here? Can you guess any point? You can, right? One point will be, any point which satisfies this equation will be on P1. So it'll be, you can use 0, k, 0 will be on the point, on the plane. 0, k, 0, you dot them will be k, right? Correct or not? You can have, this can be 0, k, 0. You can even be, say, k, 3k, and 0. You can never be like 0 minus k, k. So when you dot them, you get 2k minus k, any point on the plane. So it's this case here. What I'm going to do is this point here will be 0k0. 0k0 is the easiest. Guess any point on this plane here based on this equation. Obviously, this point you can also use one of the one that is given, which is 1 minus 3, 2. But it's not very nice. I can actually use the point 0, -1, 0, -1, 0. Okay, so I'm going to let point be points on P1 and P respectively. So from here, once I'm done already, what I can do is actually adjust the distance formula, the magic triangle. I can straight up use it because I know that the distance is CD because I'm given CD, right? I got a normal, right? Angle sandwiching between them is here. So the length that I want to find is this length. So it's this is adjacent side to the angle. So this will be cosine. Cosine corresponds to dot product. So you know that the distance between P1 and P2 and P will be CD dot n unit vector. Okay. So the rest is just doing the same thing. I think the thing is just for this method to essentially you just derive the formula without knowing it. Like you just use magic triangle. So you take a point on P1, you guess the point, then you guess another point here, then you project to the normal. Then you use magic triangle to project it, so it's a dot product, the unit vector of normal. Then this will be 12 units. So you solve it, you still get the same answer. But generally what you need to understand is that find the value A such that L do not meet the unique point, right? This means that they cannot intersect. Okay, so now meaning to say it has only to be one case, which is the line have to be parallel to the plane. Am I right? Now, line parallel to the plane is not sufficient. Your line parallel to the plane. Why is it not sufficient? Because if line parallel to the plane, this is also line parallel to the plane. Line parallel to plane. This is also line. When the line is on the plane, right? Line is also parallel to the plane. Do you agree? So essentially, what we want to do is that we want. This is where. This is what we want. This is where d dot n is equal to 0. Okay. So because the normal is here, right? The normal. So the normal dot the d will be 0. But this is where L satisfies line equation, plane equation. Okay, but because we do not want this case, so meaning to say because we do not want this, meaning to say we do not want L to satisfy P. Okay, of all the parallel planes, right, we do not want them to meet. But then do not meet in a unique point. But this is meet at a multiple point. Right? We can allow, right? Okay, can. So this is okay. Sorry, I misinterpreted because they do not want to meet in a unique point. This is not a unique point apparent. This is okay. So I'm gonna ignore. Jump. This one can ignore because this one can satisfy now because this both cases it's okay. So you have to be careful. If they say A such as L and P do not meet, then after that you need to reject this case. But this case here, this is okay because this is not actually a unique point. This is like multiple point. So you only have one thing to worry, which is you just need to d dot n equals to 0. That's it. You just want them to be parallel. I'm going to put this down. So let's do this. D dot n equals to 0 will be so there'll be 8. So this case I'll get A equals to 2. Okay, so that's how you do this question here.